नमस्कार दोस्तों, ऑडियो वीडियो क्लियर? प्लीज टेल मी, इज ऑडियो वीडियो क्लियर? Am I audible? Tell me everyone. So I think audio video is clear. Okay, wait a minute. Good evening everyone. Good evening Abdul Razzaq. Good evening. So I think, should I continue with English or Hindi? Because there are some students who feel that I should continue in Hindi, and there are some students who feel that I should continue in English. So please tell me, you want the lecture in English or Hindi? Tell me guys, you want the lecture in English or Hindi? Tell me everyone. Tell me. Hindi, okay. Tell me everyone, you want English or Hindi? Because I think the students who wanted Hindi, who want the lecture in Hindi, I think they can understand the English easily, because the engineering English is not that much difficult, so you can easily understand. But the problem is with the English student, because those there are so many students, I mean there are some other students who don't know Hindi, so that's the problem. With Hindi they can't understand it, okay, but the Hindi guy can understand the English part, because English is not that much difficult, I suppose. So I think okay, let's proceed with English then. Okay, let's proceed with English. I hope that English is okay with everyone. So actually my English is not that much great, because because usually I teach in Hindi, so I am very comfortable in Hindi. So I really want to teach in Hindi, and but anyway, it's up to you, because you guys want me to teach in English, then it's okay, because it's comfortable for everyone. So that's why, yes, I am very comfortable with Hindi, okay, and I can explain well in Hindi. But it's okay, you'll feel no problem with English also, because I'll try to, whenever I feel difficulty, I'll try to explain it in Hindi. Okay, so let's start the session guys. So this is my introduction, and please subscribe the channel if you haven't subscribed it, and like the session. This is important guys, and press the bell icon so that you get the notification. Okay, yes Abdul Razzaq, I know I can explain very well in Hindi. Yes, I know that. Okay, so yes, I'll try to make it simple. Okay, I'll try to make it simple, and I'll try to make you understand the concept easily. Okay, so you'll feel no difficulty, no problem. Okay, let's start the session guys. So this is GATE AMR series, and under this series today's lecture is about voltage source inverter, three-phase voltage source inverter. Okay, but let me tell you guys, on 18th of December there is one session which is going to be happen by this session is taken by Rakesh Talleja sir. So he is going to take this session on 18th of December. This is for GATE 2024 students, so please tell your juniors about this session, so that they can be benefited. Okay, and there is one more session, there is one more series which is going to start. This series is about GATE PYQs, last 5-year PYQs. We will try to solve almost every problem from last 5 years, so you can attend this session also. I mean this series is going to start on 18th of December again. So in that series also I'm going to take network theory and power electronics, and I suppose electrical machines also. So 2-3 subjects I'm going to take for PYQs. Let me tell you guys, this time you have to attend, you have to give some test, because the test series will help you to analyze your mistakes and your speed and accuracy. So it's important that you should join some test series and start giving the test. Now BYJU'S Exam Prep is also giving you the test series, so please join that and start analyzing yourself. Okay, in that test series you'll get many things, like at least 60+ tests which will cover entire syllabus, and There are some subject-wise tests also. There are some mock tests also. So you can give the test series. Okay. Okay. There is one All India Open Mega Mock Test for GATE 2023. You can enroll that. You can register that, and the registration is open for from 13 December to 20th December. Okay. So let's start the session, guys. So this was just introduction. So I covered this introduction part very quickly. Now let's start with the topic. The topic is our three-phase voltage source inverter. Now in three-phase voltage source inverter, we have actually two modes, two conduction mode. One is 180-degree conduction mode and one is 120-degree conduction mode. So we have to understand both of the modes. Now, if you wait a minute. Okay, yes. Wait a minute. Yes. So now this is the circuit, guys, and this is a three-phase voltage source inverter. But if you look at this circuit carefully, this is leg A, this is leg B, and this is leg C. Okay. So this switch is SC. Okay. Now in this three-phase voltage source inverter, this is my voltage source, and I have applied this capacitor. In between the capacitor, we have the zero ground, you can say reference point. So with respect to 0 volt, you can say that since both the capacitors are equal, the upper point will be VDC by 2 and the lower point will be, if this is 0, then with respect to 0, this is minus VDC by 2. Okay. So we have calculated this upper point voltage and the lower point voltage with respect to ground. Now I want to calculate the line voltage and the phase voltage and the power absorbed by this load. But there are two situations. In first case, the switch is open, and the second case, the switch is closed, because whenever the switch is open and whenever the switch is closed, everything will change. And there are two modes, 180-degree conduction mode and 120-degree conduction mode. Both are very simple. So let's try to analyze this circuit. Let's try to analyze this with this switch open and with this switch closed. So first of all, we'll start with 180-degree conduction mode. 180-degree conduction mode. Okay. Now, what is the meaning of this 180-degree conduction mode? 180-degree conduction mode means in each leg, every switch will conduct for 180 degree. Okay. Let's say this is leg A, this is leg B, this is leg C. So in leg A, this switch conduct for 180 degree, and then for the next 180 degree, this switch will conduct. Okay. This is about leg A. Similarly for leg B, similarly for leg C. Each switch in each leg, each switch will conduct for 180 degree. Okay. This is the meaning of 180-degree conduction mode. Okay. Now let's take 180-degree conduction mode and let's assume that the switch is open. Switch open. S is open. I have not closed the switch. Now, if the switch is open and if you are taking 180-degree conduction mode, then this point is A, this point is B, and this point is C, and we call this point as N, neutral point. But this is not grounded, remember. So now first of all, we need to plot the wave shape of A with respect to this O point, with respect to ground, O point, because this is VDC by 2 and this is minus VDC by 2 with respect to ground. So first of all, we need to look at the voltage VAO, this point voltage with respect to ground for 180-degree conduction mode. So let me plot the wave shape. Let me plot the wave shape. So I need to plot VAO. For 180 degree, let's say these interval are 60, 60, 60. Let me plot these interval. Every interval is of 60 length, 60 degree length, or maybe pi by 3 radian. Okay. So this is 180 degree. For first 180 degree, S1 is closed. If S1 is closed, this point voltage will be plus VDC by 2 with respect to ground. So you can say that if SA is on, then you can say that with respect to ground, this voltage will be plus VDC by 2, VAO. O means with respect to this point. I'm not asking about with VAN. Remember, VAN is different. I'm asking about VAO. So VAO voltage will be this point voltage with respect to ground, with respect to O point. So with respect to O point, if SA is on, then this voltage will be VDC by 2. So you can say that it is VDC by 2. Is it fine, guys? This is VDC by 2. Now for the next 180 degree, For the next 180 degree, you can say that SA minus is on. If SA minus is on, then this point voltage with respect to ground is minus VDC by 2. So what you can do is, now let me change the color first, okay, because I want to plot the wave with some green color. This is pi radian, so up to pi radian it's plus VDC by 2, and then from pi to 2 pi, it is minus VDC by 2. Okay, this is my VAO, guys. This is my VAO. So I have plotted VAO for 180 degree conduction mode. Is it fine? This is my VAO. This is pi, this is 2 pi, this is 3 pi. Here we have omega t. I hope you understood it. Now let's plot with VBO. Let's plot VBO and then VCO. Now I want to plot with VBO. Now VBO. Once you have plotted this VAO, you can shift it by 120 degree. Then you will get VBO. It's very simple. You know that this is 60, this is 60, this is 60, this is 60, this is 60. So every interval is of 60 degree. Okay. Every interval is of 60 degree. So you can delay it by 120 degree. You'll get VBO. So this plus VDC, if you delay it, if the 0 point is delayed, then this point will be here, this point will lie here, okay? And up to this point, it will remain positive. To this point, it will remain positive, and then it will become negative for the next 180 degree. Is it fine, guys? I hope you understood it. This is my VBO. Similarly, you can write it like this. So this is minus VDC by 2. And this is plus VDC by 2. Now, if you want to plot VCO, how to plot VCO? Again, first you take 60-60 interval, okay? Every interval is of 60 degree. So first you take the interval, each interval is of 60 degree, and then you advance it by 120 degree. If you advance it by 120 degree, then this point, this 120 degree point will come to 0. So the wave shape will look like this. This will be the wave shape, okay? I hope you understood it. So this is my VCO. It's very simple, okay? This is VCO. This is plus VDC by 2. This is minus VDC by 2. I hope you understood it. Now, if you get all these voltages, remember, this is not the phase voltage. This is not the phase voltage, okay? This is the voltage of this point with respect to O point. Similarly, the voltage of B point with respect to O point, the voltage of C point with respect to O point. Now, we want to calculate the phase voltage. Phase voltage means VAN. We want to plot VAN. What is VAN now? So, let me plot the VAN on the next slide. So, on this slide, let me plot VAN. Let's write VAN. Okay, you take 60-60 interval. Let's try to plot VAN. How to plot it? How to plot VAN? It's simple, guys. Come to this point. Now, we know that VAO is already known to us, VBO is already known to us, and VCO is already known to us. To find this VAN, the phase voltage, we need to calculate the neutral point voltage. Since neutral is not grounded, that's why this point is not 0 volt. So first, what we need to do is, we need to calculate this neutral point voltage. Once you get this neutral point voltage, then you can easily write for VAN. Now, how to get this neutral point voltage? It's very simple. So, better first plot the voltage of the neutral point voltage, VN. Plot VN, okay? VN. I want to plot this neutral point voltage, okay? Now, how to plot that? For first 60 degree. For first 60 degree, if you see, this point is at VDC by 2, this point is minus VDC by 2, and this point is plus VDC by 2. So you can say that for the first 60 degree, omega t from 0 to pi by 3, for the first 60 degree, the circuit is like this. Okay, Here you have VDC by 2. Here you have VDC by 2. Here the B phase is minus VDC by 2. Minus VDC by 2. And the C phase is plus VDC by 2. Okay. Now we need to calculate this Vn. We need to calculate this Vn. How to calculate this Vn? You can apply the nodal. If you apply the nodal, the coefficient of Vn is 1 by R, 1 by R, 1 by R, 3 by R is equal to entering current. Entering current is VDC by 2R. If you know the nodal, then you can directly write like this. Okay. So this is cancelled. So you can say that Vn will be equal to VDC by 6. So during this first 60 degree, Vn will be VDC by 6. VDC by 6. Now for the next 60 degree, let's see. For the next 60 degree, you can see that this is VDC by 2, VA. This is minus VDC by 2 and this is again minus VDC by 2. So you can say that the two voltages in the first 60 degree, 2 positive, 1 negative. In the next 60 degree, 2 negative and 1 positive. So if there are 2 positive, 1 negative, then plus VDC by 6. If there are 2 negative, 1 positive, then it will be minus VDC by 6. Okay. So it will be minus VDC by 6. Minus VDC by 6. Now come to the next 60 degree. For the next 60 degree, it is positive, it is positive, it is negative. So 2 positive, 1 negative. So if 2 positive, 1 negative, then again plus VDC by 6. Minus VDC by 6. Okay. So this will be the voltage at the neutral point. This is the voltage at the neutral point. Is it fine, guys? So we have plotted the voltage at the neutral point. It's simple. Now, it represents very interesting thing. I'll come to this point later. But anyway, we have plotted the neutral point voltage. Now, if you know this neutral point voltage, then easily you can plot VAN. VAN is VAO minus VNO. You can call it VNO with respect to ground. You can say this voltage is with respect to ground. There is no problem. So you know this VAO, you know this voltage with respect to ground. You take the difference and you will get the VAN phase voltage. You can plot easily. Okay. So now I can plot VAN. So what is VAN then? If you want to plot VAN, now you can easily plot VAN. Now you can plot easily VAN. First, show the interval of 60, 60. These are the 60 degree interval. Okay. Now I can plot VAN. For the first 60 degree, you can see that this voltage is VDC by 2 and this voltage is VDC by 6. So if you take the difference, then VDC by 2 minus VDC by 6. VDC by 2 minus VDC by 6 is, you can take the difference, VDC by 2 minus VDC by 6. So it will be 6 LCM and 3 VDC minus 1 VDC, so 2 VDC. So you'll get VDC by 3. Okay, this is VDC by 3. In the first 60 degree, you'll have VDC by 3. Now, what about the next 60 degree? Again, we have VDC by 2 and here you have minus VDC by 6. So if you take the difference, it will be added. So it will become 2 VDC by 3. 2 VDC by 3. Okay. Now for the next 60 degree, again it is positive and it is also positive. So it will become plus VDC by 2. It will be like this. Now for the next 60 degree, it will be negative, minus VDC by 3 and then minus 2 VDC by 3. So this will be the voltage, the phase voltage. This will be the phase voltage. I hope you understood it. It's very simple. So this way you can plot the phase voltages, VAN. This is VDC by 3, this is 2 VDC by 3. I hope you understood it. Okay. So we get the phase voltage. Similarly, we can plot the line voltage. Once you get this VAN, VBN, you can plot easily. You just shift this wave by 120 degree, you'll get VBN. And advance it by 120 degree, you'll get VCN. So it's very simple. I mean, the phase voltage is very easy to calculate now. Once you get this VN voltage, using nodal, you just calculated this phase voltage, the neutral point voltage, and then you can plot the phase voltage. Now, let's come to the line voltage. The line voltage is VAB. I want to plot the line voltage. The line voltage is VAB. VAB I need to plot. Okay. So first show the interval for 60 interval. These are the 60-degree interval, okay? 60 interval. And now VAB. VAB is VAO minus VBO. You'll get VAB. Okay? So if you see from the first 120-degree, this is positive and this is negative. This is plus VDC by 2, this is minus VDC by 2. If you take the difference, it will become plus VDC. So you can say that from for first 120-degree, it is VDC. It is VDC. Then next 60. Next 60, it is positive, it is also positive. So it becomes 0. It becomes 0. And then for the next 120-degree, it will become negative. And then 0. And then positive for the next 60-degree. And then 0. And then negative. So this will be the line voltage. This is plus VDC, this is minus VDC. This is my line voltage. So you can plot the line voltage VAB. It's simple. It's very simple. Now, the interesting part is, so we have plotted the phase voltage and the line voltage if the neutral point is not grounded. Now, if you look at this wave carefully, you can say that, and if you do the harmonic analysis, then you can say that this wave contains odd harmonic sine terms. Odd harmonic sine terms. Odd harmonic sine terms. Fundamental, third, fifth. So you can say that at this point you have odd harmonic sine terms. It means this AO has triplen harmonics also. It contains triplen harmonic also. Similarly, VBO and VCO, it has triplen harmonics. So you can say that VAO, VBO and VCO has the triplen harmonic component. They have the triplen harmonic component. It doesn't mean that the phase voltage will also have the triplen harmonic component. No, sir. You have to look at VAN. You have to look at VAN. So what we need to do is we need to calculate VAN, and then we will decide whether the phase contain the triplen harmonic or not. Look, this is the fundamental period. Now, if you look at this neutral point voltage, you can see that this is my 2 pi. This is one period, fundamental period. This 2 pi this can be represented here. Now you can see that in this fundamental, in this VAO, you have triplen harmonics. Third, ninth, odd multiple of 3 are called triplen harmonics. So it contains triplen harmonics. And there are some other odd harmonics also, like 5th, 7th, or maybe 11th. So there are odd harmonics including triplen harmonics. It contains triplen harmonics. Now look at the neutral point voltage. In the neutral point voltage, up to this point there are 3 cycles. There are 3 cycles. It means if the switch is not grounded, this neutral point voltage will always contain triplen harmonics only. This has triplen harmonics only. Vn contain triplen harmonic only. Triplen harmonics only. You can see that. In this wave, you will get, because this wave itself is it has the frequency 3 times of this frequency. Whatever this has the frequency, I mean whatever period this wave has, the period of this wave is 1/3 of that. It means this wave contain odd harmonics, obviously, but odd multiple of 3, you can say. Odd multiple of 3, because the fundamental, let's say fundamental frequency is omega naught here. Here the fundamental frequency is 3 omega naught. So odd multiple of 3 omega naught. So you'll get odd multiple of 3 omega naught here. In this wave, you have odd multiple of 3 omega naught. Those components are there. But here, if you look at this wave, then you have odd multiple of omega naught. Odd multiple of omega naught, okay? Here the harmonics are odd multiple of omega naught, but in Vn, you have odd multiple of 3 omega naught. Odd multiple of 3 omega naught means this wave, this neutral voltage contain only the triplen harmonics. And this voltage contain triplen harmonic as well as some odd multiple of omega naught, like fundamental, 5th, 7th, including triplen harmonics. So at this point, at VAO, you have triplen as well as other odd harmonics. At this point, you have only triplen harmonics. At this point, you have only triplen harmonics. So if you take the difference, if you take the difference, in the phase voltage, you will not have triplet harmonics because triplet harmonic will be cancelled. Here also you have the triplet harmonic, here also you have the triplet harmonic. Now if you take the difference, triplet harmonic will cancel. So you can say that when the switch is not closed, the phase voltage does not contain triplet harmonic. Okay, the phase voltage does not contain the triplet harmonic. Is it fine, guys? Have you understood this point? Have you understood this point? Tell me, guys. Okay, I hope you understood it. Let me repeat this again. I told you, if you look at this VAO, in VAO, let's say fundamental frequency is omega naught. So this wave contains the odd harmonics of omega naught. You can say that it has the sine component which whose frequency is odd multiple of omega naught. It means it contains odd harmonics of omega naught. Odd harmonics like 1 omega naught, 3 omega naught, 5 omega naught, 7 omega naught, 9 omega naught. So it contains all the odd harmonics, including the triplet harmonic like 3 omega naught, 9 omega naught. But if you look at the neutral point voltage, this neutral point voltage, the fundamental frequency of this neutral point voltage is 3 omega naught. If fundamental is omega naught here, then the fundamental frequency for this neutral point voltage is 3 omega naught. Since this wave is again a square wave, so you can say that in this Vn we have odd harmonics of 3 omega naught, odd multiple of 3 omega naught, and odd multiple of 3 omega naught will always be triplet harmonic. We call them triplet harmonic. Odd multiple of 3 is called triplet harmonic. It means you can say that the neutral point will contain triplet harmonics only. So at this point we have triplet harmonics only. At this point we have all the odd harmonics. If you take the difference, then triplet harmonic will cancel. The triplet harmonic will cancel. So you can say that the phase voltage does not contain the triplet harmonic here. Okay, this voltage does not contain the triplet harmonic. If you calculate the third harmonic component in this wave, it will be 0. Third harmonic component will be 0. Okay, I hope you understood it. So the phase voltage does not contain triplet harmonic voltage. Now what about the line voltage? In line voltage also, if you take the difference of VAO and VBO, this is my VBO. If you take the difference VAO minus VBO, VAO has odd harmonics including triplet harmonic. Similarly, VBO has odd harmonics including triplet. If you take the difference, triplet will cancel because triplet harmonics are always in same phase. That's why they will cancel. If you take the difference, triplet harmonic will cancel. So you can say that in line voltage also there will not be triplet harmonics. So here in this case, line voltage also there will not be triplet harmonics. I hope you understood it. So triplet harmonics will not be present in line as well as phase if switch is not closed. I hope you understood it. Is it fine, guys? Is it fine? I hope you understood this point. So if the switch is not closed and for 180-degree conduction mode, if you look at the wave shape, then you can say that the phase as well as the line does not contain triplet harmonics. But this point, this voltage with respect to ground will contain triplet harmonic. But this is not important. This VAO is not important for us because the phase voltage is important or the line voltage is important for us. Okay, I hope you understood this point. Now let's come to the power. How much power this load will consume? It's very simple. What you can do is you can calculate the RMS value of VAN. So the power loss, power consumed will be VAN RMS square upon R multiplied by 3. This will be the power consumed by the load. Okay, if the switch is open, because I'm taking the switch is open. Okay, so if the switch is open and you need to calculate the power loss in the three-phase load, then what you can do is you can calculate the phase voltage and then take the RMS value of the phase voltage, take square of it, divide by R. This is the power loss in one phase. Multiply by 3, you'll get the total power loss in the three-phase circuit. I hope you understood it. How to calculate the RMS value? RMS you can calculate for this wave. You can calculate the RMS. I think RMS you know how to calculate. It's very simple. Okay, so this way you can solve for this. Now let's close the switch. Now we remain on 180-degree conduction mode. Okay, I'm discussing 180-degree conduction mode. First the switch was open. Now let's close the switch. If I close the switch, if the switch is closed, then you can say that now the neutral point itself will become O point, ground. ground will be available here. Okay, if the switch is closed, let's say, if the switch is closed, then you can say that the neutral point voltage will become 0 itself, or you can say this O point will be available here. This neutral point will be equal to O point. So now this VAO will become VAN. Is it fine, guys? Now this time you can say that if the neutral is grounded, then you can say that VAO will also equal to VAN, because N point is O point itself. Is it fine, guys? Okay. So please explain RMS value. I don't want to explain, Ashok. Please look at your basics. Okay. I don't want to teach RMS value, because RMS is very simple thing. I'm not going to teach you about RMS, how to calculate the RMS value of this wave. Okay. So please look at your basics. So now let's come to the concept again. If I close the switch, if the switch is closed, then this neutral point will be equal to O point. This neutral point will become the grounded. I mean, this will be grounded. Ground means O point. So this neutral itself will become O point. It means this phase voltage will be VAO now. So you can say that this VAO itself is a phase voltage now. This is a phase voltage now. We don't need to calculate this VN. We don't need to calculate the VN becomes 0 now. So you can say that if the switch is grounded, then you can say VAO itself become the phase voltage. And now this phase has triplen harmonic. Now this phase voltage has the triplen harmonic. Is it fine, guys? Now the phase voltage has the triplen harmonic. Line will not have the triplen. Line voltage will remain same, because ultimately line is VAO minus VBO. Na? Here also the line will remain same. The line voltage will remain same. Line voltage will remain same. The phase voltage will change. VAN will be same as VAO now. And the phase will contain triplen harmonics. Phase voltage will contain triplen harmonics. I hope you understood it. Okay. Now this time phase voltage will contain triplen harmonics. If the phase contain triplen harmonics, so the phase current will also have the triplen harmonic current. The phase current will have the triplen harmonic current. If the phase has the triplen harmonic current, then if you add them, it will not be 0, because there are 3 currents, no? IA, IB and IC. IA contain triplen harmonic current, IB contain triplen harmonic current, IC contain triplen harmonic current. And we know that triplen harmonic currents are always in same phase. They are in same phase. They will not be 120 to one another. If it is fundamental, if the fundamental current is there, then the fundamental current of each phase is 120 degree apart. So if you add them, the sum will be 0. So you can say that the sum of these current IA plus IB plus IC, IA plus IB plus IC, now that will be equal to, because they contain the triplen harmonic also, no? The switch is closed. If the switch is closed, they contain triplen harmonic. And if you take the sum, then the sum of triplen harmonic will not be 0. This sum will be equal to IN. This sum will be equal to this current IN. And this will not be 0 this time. This will not be 0, because their triplen harmonic component will be added, and that current will flow through the switch. The switch will contain only the triplen harmonic current. Okay. The switch will contain only the triplen harmonic current. Because if you look at the fundamental current, IA, IB and IC, if you add the fundamental component of the current, it will become 0, because they are 120 degree apart. Similarly, if you are going to add 5th harmonic, 7th harmonic, the total sum will be 0. But for triplen harmonic like 3rd, 9th, 15th, if you are taking the triplen harmonic current and if you add them, they will not be 0, because they are in same phase. That's why they will be added and they will flow through the neutral point, through this ground point, through this switch. Okay. So you can say that now this current will be, this wire will contain the triplen harmonic current. This wire will contain the triplen harmonic current. Is it fine? I hope you understood. If the switch is closed, many things will change. Line voltage will not change, phase voltage will change. Now the phase voltage is this. This is the phase voltage, and it contains triplen harmonics. Since the phase contains the triplen harmonics, so the phase current will also have the triplen harmonic. Every phase has triplen harmonics. And if you try to add them, it will not be 0. It will not be 0. The sum of these current will be only the triplen harmonic current. The fundamental will cancel, 5th will cancel, only third, ninth, 15th, the triplet harmonic current will not be zero, and that triplet harmonic current will flow through the switch. I hope you understood it. It's very important, guys. Whenever the switch is closed and whenever the switch is open, okay, please try to understand this. So I told you about 180-degree conduction mode, whenever the switch is open and whenever the switch is closed. In open situation, the things are different. In closed situation, the things are different. Now, what about the power loss? In case of the power loss, whenever the switch is closed, then the phase voltage is this. This is my phase voltage. If this is the phase voltage, then the RMS value of this phase voltage is VDC by 2 itself. VDC by 2 itself is the RMS value. Now you can calculate the power loss in this R and take the square of it, RMS square, and divide by VRMS square divided by R, multiply by 3. So now what you can do is, now the power loss is, now the power consumed is 3 times of VAO RMS square upon R. Now VAO itself is the phase voltage, na? So VAO RMS square upon R into 3. This time you have to solve like this, okay? And VAO, what is the RMS value of VAO? RMS value of this VAO is VDC by 2 itself. So if you put the VDC by 2 value here, so you will get 3 times of VDC square upon 4R. This much of what will be the power loss if S is closed. If S is closed. And this will be the answer if S is open. If S is open. You need to calculate VA and RMS. Because if S is open, this will be my VN. This is my phase voltage. Okay. I hope you understood. Sir, in both the cases, RMS value same or not? No, RMS value will not be same. In the upper case, whenever the switch was open, you have to calculate the RMS value of VN. VN RMS will be different. And VAO RMS is VDC by 2 itself. If you know how to calculate RMS, then you can directly say that here the RMS value is VDC by 2. So you'll get different power loss. Okay. I hope you understood it. So this was about 180-degree conduction mode. And I have calculated all the power loss and wave shape, phase voltage, line voltage. Line will never contain triplet harmonic, whether switch is closed or switch is open, and line voltage will remain same. It is independent of switch position, okay? But the phase voltage will change. It may contain third triplet harmonic, it may not contain triplet harmonic, it depends on the switch position, this switch position. Now let's come to 120-degree conduction mode. In 120-degree conduction mode, what will happen, guys? So now let's take 120-degree conduction mode. 120-degree conduction mode. Now again, we have switch open and switch closed. Switch open and switch closed. What is the meaning of 120-degree conduction mode? 120-degree conduction mode means in each leg, each switch will conduct for 120 degree, and the next 60 degree it will remain off. And then for next 120 degree, the lower switch will be on, and then next 60 degree it will off. So alternatively this will work. First this for 120, then switch off, and then for next 120 it will on and then switch off, and then for next 120 degree this is like this. So let me draw the wave shape. First switch open, S is open. If my switch is open, if the switch is open, this point will become the neutral point N. This point we call it VAO. VAO. We call it VAO. Because with respect to O point, I am drawing the wave shape. This point we call VBO. This point we call VCO. So let's plot the wave shape. Let's plot the wave shape. VAO, VBO, and VCO. Okay. For every 60 degree, let's take this interval as 60 degree. 60. Okay, these are 60 degree interval. Similarly here is a 60 degree interval. Again 60 degree interval. Each interval is of 60 degree. Okay, fine. Now first of all, VAO. For first 120 degree it will be on. So the output, so the VAO, this point voltage with respect to O point is VDC by 2. VDC by 2. So up to 120 degree it is plus VDC by 2. VDC by 2. Then it will become 0. Then it will open. it will become 0. And then for next 120 degree, it will be on. So it will become minus VDC by 2. And then it will become 0. And then it will become positive. And then 0. And then negative. Okay. So the wave shape will look like this. Minus VDC by 2. This is minus VDC by 2. Okay. So this is VAO. Now let's come to VBO. 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 This is omega t. Now let's plot VBO. VBO is just shifted version of this. You can delay this wave, you'll get VBO. So what is VBO? If you delay by 120 degree, this point, this 0 point will come to 120 here. Okay. And then 0. And then negative. And then 0. So I delayed the upper voltage and I'll get VBO. Okay. Here 0, here you will have the negative value. Okay. This is my VBO. Now VCO. Just advance it by 120 degree. If you advance it by 120 degree, this point will come to 0. Okay. So the 0 line will appear first and then negative and then 0 and then positive and then 0 and then negative. Is it fine, guys? This way you can plot VCO. So we have plotted VAO, VBO and VCO. Now what I need to do is I need to plot the neutral voltage, because once you get this VAO, VBO and VCO and the neutral voltage, then you will be able to plot the phase voltage. Line voltage you can directly plot now, because we know VAO, VBO, you just take the difference, you'll get VAB. So now I want to plot the neutral voltage first and then phase voltage and the line voltage for 120 conduction mode. Okay. So first I want to plot Vn, neutral voltage, and then the phase and the line. Okay. So these interval are of 60 degree. Every interval is of 60 degree. Okay. This is 60 degree. Okay. Now, first neutral voltage Vn. I want to plot Vn. Look at the neutral voltage first. This point voltage. So for first 60 degree, let's see what will be the voltage. At this point, at A point, it is VDC by 2. It is VDC by 2. At B point, it is minus VDC by 2. And at C point, it is 0. 0 means open. No switch is connected here. Okay. No switch is connected here. It means it's open. So you can open it. You can ground it. Don't make it 0 volt. You just open it. Okay. There is no switch connected. 0 means there is no switch connected here. Okay. So you can say that this is VDC, this is minus VDC. So this voltage will become 0 volt. If you apply nodal here, this voltage will become 0 volt. So you can say that for the first 60 degree, neutral voltage is 0. Now let's come to the next 60 degree. For the next 60 degree, one is positive, one is 0, one is negative. 0 means open. So here you have positive, here you have negative. So one is positive, one is negative. So middle point will be 0, because the third point is open. Let me repeat this again. So the next 60 degree, if you look at the next 60 degree, what will you have? A point is VDC by 2. This is VDC by 2. Okay. And the B point is open. B point is open. C point is minus VDC by 2. Now you have this VDC by 2. This is minus VDC by 2. This point has to be 0 volt. So you can say that neutral will remain 0. Again, in the next, it will remain 0. Again 0. Again 0. Again 0. So you can say that the neutral voltage will always be 0. Neutral voltage will always be 0. This voltage, whether the switch is open or switch is closed, this voltage will remain 0 here. Okay. This voltage will remain 0. In 120 degree conduction mode, if you look at the neutral voltage, it will always remain 0, whether the switch is open or whether the switch is closed. It means this VAO itself will become VAN, because if it is 0, it means it is grounded again. It is grounded. If it is grounded, it means this point become O point. This point become O point, whether the switch is closed or whether the switch is open. So you can say that in this situation, VAO itself will become VAN. So this is my phase voltage now, and this is my, VAO itself will become the phase voltage. VAO itself will become the phase voltage. Whether you close the switch or open the switch, it doesn't matter. Now it doesn't matter in 120 degree. In 120 degree, even if you close it, there is no problem. The phase voltage will remain VAO, N voltage will always remain 0. Is it fine? Now, this wave does not contain triplen harmonic. This wave does not contain triplen harmonic because the switch is open. If the switch is open, the triplen harmonic current cannot flow. It means the triplen harmonic current will not be there in the phases because it does not have any path. It does not have any path. If the switch is open, triplen harmonic current cannot be there in the phases. So if in the phases, if there is no triplen harmonic current, there will be no triplen harmonic voltage. And we know that the phase voltage is VAO itself. So it means it does not contain triplen harmonic voltage, since it does not contain triplen harmonic current if the switch is open. Now, if the switch is closed, then also the voltage not change. The VN point remains 0. So you can say that whether the switch is closed or whether the switch is open, there will be no triplen harmonic voltages in phase. There will be no triplen harmonic voltage in phase. And in line also, line is the difference. In line, there is no triplen harmonic voltage. In line, you have to take the difference. Even if this VAO or VBO have triplen harmonic, line will not contain it. Though in this situation, in 120 degree conduction mode, VAO and VBO does not contain triplen harmonic, and this itself will become the phase voltage. This itself will become the phase voltage, okay? VAO, VBO, VCO itself is a phase voltage, and it does not contain triplen harmonic. I hope you understood it. This is again a very nice situation. In 120 degree mode, whether you close the switch or open the switch, it doesn't matter. It doesn't matter. VAO itself will be the phase voltage, and it does not contain triplen harmonic even if the switch is closed or the switch is open. Okay, so I hope you understood this problem. I hope you understood this concept. This is again very interesting case, guys. 120 degree conduction mode. Now you can plot the line voltage. There is no problem with the line voltage. So VN will always be 0. VAN will be equal to VAO. So there is no need to plot it again. It will again be VAO. Now you can plot VAB. Now you can plot VAB. VAB is VAO minus VBO. So if you take the difference for first 60 degree, it is VDC by 2, it is minus VDC by 2. Take the difference, it will become plus VDC. It will become plus VDC for first 60 degree. Next 60 degree, it is plus VDC by 2, it is 0. So the difference is VDC by 2. Now for next 60 degree, it is minus VDC by 2, it is plus VDC by 2. For next 60 degree, it is 0 and it is plus VDC by 2. So if you take the difference, you'll get minus VDC by 2. You'll get minus VDC by 2. For the next 60 degree, it is negative, it is positive. If you take the difference, you'll get minus VDC. Okay, so this is the line voltage now. This is the line voltage, guys. I hope you understood it. This is the line voltage now. So it's easy peasy. I mean, you need to plot the difference. And the line will not contain the triplen harmonic. Line will never contain triplen harmonic. Okay. Is it fine, guys? I hope you understood it. Now, if the load is not connected in star, let's say, if the load is connected in delta, okay, you can always convert it into star, equivalent star, without neutral, okay. Let's say the load is delta. Let's say the load is delta and it's like this. And let's say this is given as 999. This point is connected at A, this point is connected at B, this point is connected at C. Now what you can do is, you can always convert this into equivalent star. You can convert it into equivalent star. Okay. 9 into 9 divided by 27. So it will be 3 ohm. This is 3 ohm and this is 3 ohm. But whenever you connect it into equivalent star, don't close this neutral point with the ground. It means it is equivalent to star without neutral, without closing this point. Okay. So you can always convert it like this. There is no problem. And you can solve accordingly. Because if delta is there, you can convert them into star without connection of this neutral point. Don't connect this, because in delta we don't have neutral point. Okay, that's why whenever you convert it into star, don't connect this neutral point with the ground. I hope you understood it. So this was again very easy. So I hope you understood it. Tell me guys, is it fine? Is it fine? So this was about three-phase voltage source inverter. I have given you all the ideas, and I have told you about every concept. I hope you understood all the topics. So please revise your three-phase voltage source inverter situation, because there are some other situation also. Let's say this point is not grounded. Let's say this point is not grounded. This point is grounded. Then what will happen? So there are some other situations also. So you have to understand those situations also. So do it yourself. This is your homework. Okay. So that's all for today's session, guys. I hope you enjoyed this session. So in the next session, we'll discuss about PWM. Okay, sinusoidal PWM. So we'll discuss about PWM, and the next session will be on Monday, I suppose. So you will get notified. Just press the bell icon. Okay, just press the bell icon and you will get the notification. If you have not subscribed it, please subscribe the channel. And this is mobile app link, which is the mobile app is also there. So the link is provided in the description. You can download or install the mobile app from Google Play Store, and you can watch free sessions on app also. Okay, so that's all for today's session, guys. I hope you enjoyed today's session. See you in the next session. Thank you and take care. Bye.